Okay, everybody, today we're going to look at solving polynomial inequalities. And what we really have to do when we solve a polynomial inequality is we're looking to figure out the values of x that will make f of x be either 0, that would be an equation actually, greater than 0 or less than 0. So let's fill in that graphic organizer at the top here. So I want you to think about what it means when we say what values of x make f of x have this equation be true. And so here we're looking for the 0 values. We can also think about what this would mean if we were talking about the graph of the polynomial function. If we're talking about the graph of the polynomial function, then these will be the x-intercepts of the graph. If we want to solve a polynomial inequality f of x is greater than 0, then what we're looking for here is the values of x that will make f of x, the y values, positive. And if we think about the graph of the function y equals f of x, this would be when the graph is above the x-axis. If we want to solve the polynomial inequality f of x is less than 0, we're looking for the values that make it negative. And I bet you can guess, this would be when the graph of y equals f of x is below the x-axis. Turn that a little bit. Okay, so we want to be below the x-axis. So we're just going to start off by figuring out when a given polynomial function is either positive, negative, or 0. And so I've given you a polynomial function here that's already in factored form. And on this particular polynomial function, what we want to do is start off by figuring out the 0 values. Because if we can figure out the 0 values, then we can pretty easily figure out when it would be positive or negative in between those numbers. So let's take a look at these numbers here. And I can see that this is going to be equal to 0 at 1, at negative 3/2, and at 2. So I'm going to arrange those numbers on a number line in order from smallest to largest. So I'll put negative 3/2 on my number line. I'll put 1 on my number line. And I'll put 2 on my number line. Now, one of the ways that we can solve these types of equations is by actually using what we call a sign chart. And so we're going to do this down here when we actually solve an inequality, but we'll go ahead and get started with this with just doing this one. And I'm going to pick a number in between each of these 0 values and use it to test the sign of this expression. So I need to think of a number that's smaller than negative 3/2, like negative 2. If I substitute negative 2 into each of these factors, you can see that this factor is going to be negative. This factor, if I plug in negative 2, will also be negative, because I'd get negative 1. And if I plug negative 2 into this factor, I'd get negative 4, but we're squaring it. So that will come out to be positive. So looking at the signs here, we can see negative times positive is going to give me an overall positive value. If I select a number in between negative 3/2 and 1, the easiest choice is going to be 0, and substitute 0 into each of these expressions, I'm going to get negative 1, which is negative. I'll get 3, which is positive, and I'll get negative 2, but I'm going to square it, so that's going to come out to be positive. So I can see here that this polynomial is going to overall be negative, because a negative times a positive is negative. When your 0 values are right next to each other in terms of the integers, it's a little bit trickier to pick your number because you're going to have to pick a fraction. So I'll use 3/2 here. You might be getting the idea though. If I pick 3/2 or 1.5, this will be positive. This will be positive because everything is positive, and this one also positive, again, because we're squaring it. So we will have positive times positive times positive, overall sign positive. And I bet you can guess what's going to happen when we pick a number larger than 2. Easily, all 3 of these factors, if I substitute in any number larger than 2, are going to be overall positive. So I've now gotten myself into a position where I can answer this question. The 0 values are at negative 3/2, 1, and 2. The positive values, we have to answer using an interval. So the intervals where this graph is positive are from negative infinity to negative 3/2 and from 1 to 2. Notice I'm not using the brackets because that's where the graph is equal to 0. The negative interval, there's only one of them. Oh, sorry, I forgot that one, 2 to infinity. The negative interval, there's only one, and that's going to be negative 3/2 to 1. We could have also answered this question by thinking about the graph of this polynomial function. We go over here and sketch it really quickly. It's a 4th degree, so I know it's going to start and end high. And same thing, put my intercepts on there, negative 3/2, 1, and 2. And so this graph is going to have to go something like this. But remember the bounce, because the x squared, the x minus 2 factor was squared. And this takes us back to what I wrote down up here. The 0 values are at the x-axis. The positive values are above the x-axis. So that's why we had that's why we had from negative infinity to negative 3/2, from 1 to 2, and from 2 to infinity. All right, let's go ahead and solve this next one graphically. So I'm actually going to sketch the graph of this polynomial function after I finish factoring it. We want to figure out the values that make this one less than or equal to 0. So that means at the x-axis, the x-intercepts, or below the x-axis. So if we lay those 0 values on here, negative 4, negative 3, and 3, this is a cubic polynomial. We could calculate the y-intercept. It's negative 36. I know that it's going to start low and end high. Okay, so I'm looking for the places where the graph of this function is equal to 0 or less than 0. So that's going to be the x-intercepts and anywhere that the graph is below the x-axis. So I can see that the graph is below the x-axis. In fact, let me grab a highlighter. Graph is going to be below the x-axis for these values of x and for these values of x. So that's going to be my solution. Let's write it with intervals. Negative infinity to negative 4. Notice I'm including the negative 4. And then we can use the union symbol, or you could just use the word or. And my next interval is negative 3 to 3. And there's the solution to that polynomial inequality done graphically. Okay, next one. We're going to solve using a sign chart. So the sign chart is what I constructed up here. But we first of all have to factor this. So the challenge on this one, of course, is going to be finding the factored form. So the p divided by q method is going to give me p values of 1 and 3, q values of 1 and 2. So my p divided by q list is going to be 1 divided by 1, 3 divided by 1, 1 divided by 2, and 3 divided by 2. All right, so we need to use synthetic division to try to solve this. Recording. So just be quiet, I'm recording, Nate. All right, so let's see if we can do our synthetic division on this one. 2, 1, negative 4, negative 3. All right, I can kind of look at the arrangement of these numbers here, and I can see that there's really not a way that they're going to add up to either make 1 or negative 1, I don't think. So I think what I'm going to be inclined to do here is I think I might try 1/2. So let's see if 1/2 works for us. In fact, I better grab a pencil just in case it doesn't. Let's pull down the 2. 1/2 times 2 is 1. When I bring down the 2, I'm going to get 1 again. And that's going to give me negative 3. And I can see that 1/2 isn't going to work. So let's try 3/2. Hey guys, I'm recording, so be quiet, okay? Here, you know what, I'll just pause it.
You're recording yourself.
Okay, so we figured out that 3/2 will probably work for a 0. You can see the synthetic division here. I brought down the 2. 3/2 times 2 is 3, Adding, we get 4. 3/2 times 4 is 6. Adding, we get 2. 3/2 times 2 is 3, and that's what we needed to make that 0 remainder. So the factored form of this expression is going to be, I think I can use pen now, x minus 3/2, and then this is my reduced polynomial, so we'll have 2x squared plus 4x plus 2. Now I can factor a 2 out of there, and then I can finish factoring that trinomial. So x squared plus 2x plus 1 factors like this. X plus 1 times x plus 1, because I need the numbers to multiply to 1 and add up to 2. And if I just do a little bit more work on this, maybe I'll pull that 2 out in front, I can rewrite this as x plus 1 quantity squared. So we can see that there are only 2 values that are going to make that polynomial equal to 0. Even if you're not trying to find the 0 values, even if you're trying to figure out when this is greater than 0, you still have to start by finding the values that make the expression 0. And we said we were going to use a sign chart for this one. So I'm going to draw a number line. I'm going to put the 0 values on my number line. So -1, and then this 0 value is 3/2, so that's 1.5. And now we have to select numbers that are in between these 0 values and test the sign of this expression. It's easiest to do when it's in factored form. So I can pick a number smaller than -1, like -2. If I plug -2 in here, this factor is going to be negative. If I plug -2 in here, even though this will be a negative number, I'm squaring it, which makes it positive. So I'm going to have a negative times a positive, and that overall is going to be negative. When I pick a number between -1 and 1.5, 0 is a logical choice. I'm going to get a negative factor and a positive factor, again, because I'm squaring it. And so will also be negative on this interval. And then greater than 1.5, if I pick a number like 2 or 3 or 4, any number larger than 1.5, I can see that this factor is now going to be positive, and this factor is always going to be positive. So we'll have a positive factor multiplied by a positive factor. Overall, our sign is positive. We were trying to determine when this polynomial inequality was true, so we were looking for the values of x that made this expression positive. So I can see that that's only going to be the interval of numbers from 1.5 on. So the solution, if I write it as an interval, is going to be 1.5 to infinity. Okay, this is how you solve polynomial inequalities. Again, you always want to find those 0 values. So this is a logical extension of what we were doing before when we were graphing polynomial functions and finding the zeros of polynomials. In addition to being able to solve this graphically, the other method would be to make a sign chart, which we used here and we used down here on this problem.